To succeed in finding the cofactor of a particular element in a given matrix, you need to understand what we call minor matrix. A minor matrix is a 2 by 2 matrix that you will have when you eliminate a particular row and column in a given 3 by 3 matrix. So what are we saying makes sense? First, the minor matrix is represented as lowercase m sub r by c, where this can be read as row by column, which should correspond to the dimension of the element you are trying to find its minor matrix. So how can we determine it? Let's make use of some examples. Consider a matrix A to be 3 by 3 matrix and is divided with the following elements: 0, 0, 1, 2, minus 1, 3, 1, 1, 4. How can we find m sub 1 by 1? That means we should find the minor matrix of the element in the first row, first column. So how can we find that? Keep in mind, it's going to be a 2 by 2 matrix. And to find those matrices, typically the element in that matrix, eliminate all the elements in the first row and that of all the elements in the first column. Whatever element you are left over with will be your final answer. And that's just going to be minus 1, 3, 1, and 4. And that's it. Now, what about the minor matrix of the element with the following dimension, 2 by 1? That means the element in the second row, first column. So the goal is to eliminate the element in the second row and the element in the first column. So whatever element we are left over with will be our final answer, which will be 0, 1, 1, 4. 0, 1, 1, 4. And that is how to easily and mentally solve for the minor matrix of a particular element with a given dimension. Now that you understand the minor matrix, it's easy to understand the cofactor of a particular element in a given matrix. The cofactor is represented as C sub row by column, where this is the dimension of the element in that given matrix, and is given as negative 1 to the power of the sum of that dimension, that's R plus C, then multiplied by the determinant of the minor matrix of that same element in that given dimension, R sub C. R by C rather. So whatever answer you have here will be the cofactor of that element. To understand this properly, let's consider an example to demonstrate that. Consider the same matrix A, which consists of the elements 0, 0, 1, 2, negative 1, 3, then 1, 1, 4. Let's find the cofactor of all the elements in this given matrix. So the first one will be the cofactor of the element in the first row and first column. That's 0, because 0 corresponds to the element in the first row and first column. Perfect. So its cofactor will be equals to negative 1 to the power of 1 plus 1. And we are multiplying that with the determinants of its minor matrix. So its minor matrix will be this matrix. So that's good. That's going to be negative 1, 3, 1, 4. Perfect. Simplifying this forward, we would end up with negative 1 to the power of 2. Then let me just find the determinant straightforward. Negative 1 times 4. Don't forget you have to multiply the element in the leading diagonal first. Negative 4. Then you subtract the product of the element in the other diagonal. That's 3. So we have 1 multiplied by negative 7, which will be minus 7. So sometimes you might be required to find the matrix of the cofactors. So the cofactor of matrix A, generally speaking, let me just write this as COF, will now be equals to another bigger matrix, which will be 3 by 3 matrix, which its first element will be negative 7. We are going to find the corresponding ones. Now, the element in the first to second column, C sub 1 by 2. That's going to be negative 1 to the power of 3. I've just had them up straightforward. Now, what element, or what will be the minor matrix of the element with this dimension? So let's eliminate that. First to second column. So we are left over with 2, 3, 1, 4. 2, 3, 1, 4. Simplifying this, we have negative 1, because negative 1 to the power of 3 is negative 1. 2 times 8, that's going to be 8. Sorry, 2 times 4, that's just 8. And then 1 times 3, that's 3. So we're subtracting that. Left over is negative 5. What position is it? First to second column. That's going to be this. Negative 5. Perfect. Now, the element in the first to third column. Typically the cofactor. So C sub 1 by 3. That will be equals to negative 1 to the power of 4 by the time you had the dimension. Then the determinant of its minor matrix. So what will be the minor matrix of the element with this dimension? First row, third column. So you notice that that's just 2, negative 1, 1, 1. 2, negative 1, 1, 1. Perfect. Simplifying this, we have 1 multiplied by 2 times 1, that's 2, minus negative 1 times 1, that's negative 1. Then we end up having 2 plus 1, which will be 3. So that is our final answer. Now, the element in the second row, first column. So we are considering the cofactor. Oops, the yellow color is not that clear enough. Let me try and use blue. Element in the second row, first column. So that will be equals to negative 1 to the power of 3. Then what will be its minor matrix? Second row, first column. That's 0, 1, 1, 4. Oops, I need to get rid of that first. 0, 1, 1, 4. Simplifying this, we have negative 1 multiplied by 0 times 4, that's 0, minus 1 times 1, that's just 1. So we end up having negative 1 multiplied by negative 1, which will indeed equals to 1. Perfect. Now, on to the element or the cofactor of the element in the second row, second column. That will be equals to negative 1 to the power of 4. Now, what will be its minor matrix? Second row, second column. That's 0, 1, 1, 4. Perfect. So we have 1 multiplied by 0 times 4, that is 0, 1 times 1, negative 1. So that will be equals to -1. Perfect. Now element in the second row, third column. That will be equals to -1 to the power of 5. Then multiply by what will be its minor matrix. Second row, third column. That's just 0, 0, 1, 1. I don't know why I kept on forgetting to delete first before writing. So we have -1 multiplied by 0 times 1, that's 0 minus 0. So that's just indeed equals to 0. Perfect. So we're almost there. I hope you should have been noticing the pattern. You should have been getting used to it. On to the element in the third row, first column. -1 to the power of 4. Now what will be its minor matrix? Third row, first column. That will be 0, 1, -1, 3. 0, 1, -1, 3. So we find that we have 1 multiplied by 0 minus 1. Now we 1 multiplied by 0 plus 1, which will be indeed equals to 1. Onto the element in the third row, second column. Third row, second column. -1 to the power of 5. Now what will be its minor matrix? Third row, second column. So that will be 0, 1, 2, 3. 0, 1, 2, 3. Perfect. So that will be -1 multiplied by 0 minus 2. That will be -1 multiplied by -2, which will be +2. And lastly, we are considering element in the third row, third column. Element in the third row, third column. So that will be equals to -1 to the power of 6. Now what will be its minor matrix? Third row, third column. That will be 0, 0, 2, minus 1. So that will be 1 multiplied by 0 times -1, that's 0, minus 0 times 2, that's 0. So that will be 1 multiplied by 0 minus 0. That will be indeed equals to 1 times 0, that's 0. So we have 0 here. And that will be our final answer. Hopefully you now know how to find the cofactor matrix of a given matrix. Similarly, the minor matrix of a particular element with a given dimension. Likewise, the cofactor of a particular element with a given dimension in a given matrix. Thanks for watching. See you guys in the next video. However, I have an exercise for you, and this is your exercise. So find the cofactor matrix of the given matrix B, which is equals to 1, 2, 1, 2 minus 1, 2, 1, 1 minus 2. So I'm not asking you to find the cofactor of a particular element in matrix B. I want the cofactor of its whole element. That's the cofactor matrix of matrix B. That is cof B. Let me know your solution in the comment section below. Feel free to share it with me. Thanks for watching. See you guys in the next video. Bye for now.